Ever wondered how fast a falling object can really go? Spoiler alert, there's a point where gravity and air resistance play tug of war. Let's break down the science behind terminal velocity. Terminal velocity is the maximum velocity reached by a freely falling object in a fluid. The fluid can be air or liquid. When an object is freely falling, the downward force or weight of an object accelerates the object downward due to the force of gravity. Initially, the object is not affected by the air resistance. As the object continues falling, the upward force or air resistance gradually increases, hence reducing its acceleration. Finally, the force of gravity pulling the object downward equals the air resistance pushing the object upward. In other terms, the downward force equals the upward force. At that point, the object ceases to accelerate but continues moving at a maximum speed called terminal velocity. Did you know that a typical raindrop has a terminal velocity of about 32 kilometers per hour? It might sound fast, but it's much slower than you'd think. Terminal velocity can be represented on a velocity time graph. The first section depicts the acceleration of the object. At this point, the weight of an object is greater than air resistance. Then, the acceleration of the object gradually decreases as the air resistance acting on the object increases as depicted by the second section. Finally, the object reaches a maximum speed and continues moving at its maximum speed called terminal velocity. At this point, the weight of an object equals the air resistance acting on the object. Here's a challenge for you. Try to guess the terminal velocity of a skydiver. What do you think it is? Drop your guess in the comments. There are 4 factors that affect the terminal velocity. The first factor is the mass of the object. Heavier objects have higher terminal velocities because the gravitational force is greater. So the larger the mass of the object, the greater the terminal velocity. The second factor is the cross-sectional area of the object. Objects with a larger cross-sectional area experience more air resistance, leading to a lower terminal velocity. The third factor is the shape of the object. Heavy objects fall faster because gravity has more of a grip on them. But here's the catch. Even a small object can have a high terminal velocity if it's shaped just right. Streamlined shapes experience lower drag force, resulting in higher terminal velocity. The fourth is the air density. Higher air density increases the drag force, thus reducing the terminal velocity. To recap, terminal velocity is the maximum velocity reached by a freely falling object in a fluid. During terminal velocity, the object moves at its maximum velocity with zero acceleration. The weight of the object is equal to the air resistance. Now that you know how terminal velocity works, in the next video, we'll explore the free falling objects. Stay tuned, stay curious.